Hi, hello, welcome to lesson 2 of unit 4. Today we're going to talk about solving quadratics with complex solutions. We're also going to extend the polynomial identity. During this lesson you're going to learn how to use the quadratic formula to solve quadratics with complex solutions. And you'll also extend the polynomial identity to the complex number system. Okay, so just some quick vocabulary review. Most of these is that a number that can be divided out of another number. We know the factored form of a quadratic is f of x equals a times x minus root 1 times x minus root 2. Okay, a quadratic expression is an expression that consists of terms in which the highest degree is 2. My highest degree is 2, so it's raised to the second power. The difference of squares is a binomial in which both terms are perfect squares and one is subtracting the other, something like this, x squared minus 25. There's my difference of squares. Okay, in the last unit we learned about the quadratic formula, and we learned that the quadratic formula can find solutions of a quadratic, which are the x-intercepts. Okay. The pieces of quadratic formula come from the standard form of a quadratic, which is y equals ax squared plus bx plus c. That's where we get our a, b, and c from. So we find the a, b, and c and put them into the quadratic formula. So you now know how to deal with imaginary solutions, which means you now know how to deal with a negative square roots. Before, in unit 3, if I had a square root with a negative number in here, so we'd say like a negative 4, we would say no solutions. We know how to find that now. Okay, so let's look at this. So we want to solve the quadratic with an imaginary solution. So the very first thing I have to do is I need to identify my a, my b, and my c. I have my a value, have my b value, and my c value. So I get a is 2, b is a negative 5, and c is 11. So we've identified that. Now I can plug that into the quadratic equation. So I have negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a, which is 2. Alright, now we can just work on simplifying this. A negative 5 gives me a positive 5, plus or minus square root of negative 5 squared, 25. Negative 4 times 2 is negative 8. Negative 8 times 11 gives me a negative 88, all over 4. We need to figure out what 25 minus 88 is. So I'm going to say 3, 6. So I get 5 plus or minus the square root of negative 63, all divided by 4. Okay. Well, now I know how to deal with not just a square root or a radical, but I know how to deal with something that has a negative in it. So what I'm going to do is over here I'm going to take negative 63 and I'm going to simplify this. So first of all I'm going to say I get negative 1 times the square root of 63. I know that this square root of negative 1, this is equal to I, right? So we can take that out. Then 63, I can say is 9 times 7, 3 and 3. There's my grouping. That comes out. I have that I, that 7 still locked up. Okay. So now I can say I have 5 plus or minus 3i square roots of 7, all divided by 4, and that's my answer. Remember, this is what x equals. This is my x-intercept. This 3i square roots of 7 all over 124, and there's my answer. So what's happening graphically here, let's just think about this, is I have some quadratic. I don't know exactly where it is, but we do know that it's positive, it's above the x-axis, and that we're getting some sort of imaginary root here. Okay, I want you to try now. So pause the video and give it a try, and then watch the solution. Okay, so very first, identify your A, your B. Ooh, right here, this C, I need to add 5 because this needs to be equal to 0. So I have 8x squared plus 6x plus 5 equals 0. So A is 8, B is 6, and C is that positive 5. That's a tricky one. We have to get that equal to 0 for this to work. All right, now that I have that, I can input those numbers into my quadratic formula. So I get negative B plus or minus square root of B squared minus 4 times A times C, all divided by 2 times A. Okay, now we're just going to simplify within that. So we get negative 6 plus or minus square root of 36. So negative 4 times, I'm going to do 4 times 5 first, so it gives me negative 20. Negative 20 times 8 gives me negative 160. Feel good about that. All over 16. Okay, I'm going to take 160 minus 36 over here. I know I'm going to get a negative number. So we get negative 6 plus or minus square root of, let's see, 4 to negative 124. All over 16. Now I'm going to take that negative 124. I'm going to bring it over here. We're going to simplify it. 124. So first I'm going to do the square root of negative 1, square root of 124. Now I can simplify that 124 because we know that this square root negative 1 is just equal to I. So I'm going to get 2 and 62. I'm going to get 2 and 31. That's probably as low as I'm going to get. So now I know this is equal to 2I square root 31. So my answer is going to be negative 6 plus or minus 2I square roots of 124. Oh, not 124. We figured out what square roots of 31. 2I square roots of 31 all over 16. Now we're not quite done because I can technically simplify this a little bit more here. Notice here I have a 2 here, a negative 6 here, and a 16 here. So what I can do is I can factor out a 2 from everything. So I can say I'm going to take a 2 out. That gives me negative 3 plus or minus I square roots of 31. And then down below I can say 2 times 8. So what we did is notice that if I went backwards and I redistributed into all these things, I'd get back to my original. The reason we factored out is because I can now cancel those 2's out, and I can say negative 3 plus or minus I square roots of 31 over 8, and that would be the simplified version. Remember, that's x equals my x-intercepts. Okay, so that's just adding on to what we've done with the quadratics and combining it with our imaginary numbers that we've dealt with. Okay, now remember, we've done factoring of difference of squares. It would be something like this where I had x squared minus 25. So we look, the square root of the first term is the first term in the resulting binomial. So we have 2 perfect squares. So what we do is we first take the square root of each of the terms. So x squared would be x. The square root of 25 is 5. Okay. The next is the square root of the second term is the second term of the resulting. So if I were to factor this, it'd be x. Oh goodness. Plus 5, x minus 5, right? So the first step was the square root of the first term. It's the first term in each of the resulting binomials. So the square root of this gives me there. Right, so that's that step. That was step 1. Step 2 is the square root of the second term. So that's the square root of 25. Is the second term in the resulting binomials. There's step 2. And then step 3 right here is you have 1 plus sign and 1 minus sign. That's how we did the difference of squares. But what about a sum of squares? So now that we have the knowledge of imaginary numbers, we can now factor a sum of squares. So by when we change the constant by negative 1i squared, and then the factor the different squares like you normally would. So this is what I mean. All right, so we factor the complex number system. So instead of this is a positive 16, we write this as x squared minus 16i squared. Understanding that I squared is negative 1, so negative 1 times negative 16 would get you back to the plus 16. And then we can do this just like how we factored before. So I would say, okay, what is the square root of my first term? That's x. So when I factor this, my first term in each factorization in my factored form is going to be x. Okay. The second step would be I would take the square root of my second term, which is 16. So the square root of 16 is 4, but here's the difference. Because I have this sum here, I'm going to put 4i. So I'd say 4i and 4i. Okay, so there's step 2. Now I would have 1 plus and 1 minus. Okay. So there's the plus, there's the minus, that's the step 3. Now this works because when I distribute this now, x times x gets me x squared. X times negative 4x is a negative 4xi. Positive 4ix times, or 4i times x gives me a positive 4xi, and then I get a negative 16i squared. Now when I simplify this, I get x squared. Notice this term and this term cancel out, and I get negative 16i squared. Well, we know that I squared is negative 1, right? So I can say negative 1 times 16 gives me a positive 16, and we get back to our original equation right here. All right, I want you to try now. Then check to make sure you're for the solution. All right, step 1. We know I want this in factored form. I'm going to take the square root of the first term, which is x. There's my first piece. My second piece is I'm going to take the square root of the second one, which is 5. Okay. Then we're going to add I to the second piece. And then I have my fourth one is plus and minus, so one's a plus and one's a minus. So I get x squared plus 25 factors to be x plus 5i times x minus 5i. Alright, let's try this again. Try it again where we have the coefficient not 1. All right. Square root of the first term, 16x squared. Whenever I have a number and a variable, I'm going to take each of them separately. The square root of 16 is 4. Square root of x squared is x. That is my first term in each of these. Next, I have the square root of 25, which is 5. Remember, I'm going to add that I to the backside. Then I have a plus and a minus. There's my answer. If you have any questions, please come talk to myself or a tutor. We'd be happy to help you. Thanks. Have a great day. Bye.